always good when I forget to turn it off. Yeah. All right. Part of the new proofs I'm going to have you do today is noticing when you have what's called a contradiction or opposites of each other. All right. So I put a quick example up there first. If you could identify the two statements that contradict each other, basically two that can never happen at the same time. It's absurd if these two happened at the same time. All right. So I have PQR or coplanar, PQR or collinear. Anybody collinear? I know going back to our couple first days of school, and I liked most of you. PQ and R, what's collinear again? They're all on the same line, and then the measure of angle PQR is 60. All right, so if you want to discuss it in your group, I'll give you about a minute. Two of those cannot happen at the same time. It is geometrically impossible to happen at the same time. All right, so if you and your group want to discuss that, go right ahead. We ready? We got any groups that want to report back and say these two not happening at the same time? Maggie, what do you got?
PQR, they exist on the same line, but PQR is a 60-degree angle.
There you go. These two cannot happen at the same time. All right, here's why. If I draw angle PQR being 60 degrees, are PQR and are they collinear? No, because they're not on the same line. All right, that's impossible. Cannot happen. All right, so 2 and 3 contradict each other, can't happen at the same time. That's the philosophy. That's the thinking we're going to use to solve these proofs. Now, this is just here. Steps in an indirect proof, how to recognize one. That's just here for you guys if you ever forget tonight, tomorrow night to review. I want to just jump right in and get after it. All right, jump right into it and get after it. So let's go to that first proof there, example 1. We're diving right in. I don't need to read all the directions to you. We're diving right into it. And if I lose you along the way, please let me know. Please don't think you're just going to pick it up after the first one. We're going to do 3 of these together before I let you go on your own. All right, ladies, gentlemen, here we go. First thing I need your help with is, why the heck do I need this new type of proof? Why isn't the old way we did just go and prove what I'm asked? Well, anybody see something very, very different right now about this proof that has never happened to us all year long in any of these proofs? Right off the bat. Right off the bat. Hi, Jasmine. I have never asked you that, to prove something's not congruent. Okay? And that right there is the signal. Hey, I'm asking you to prove something is not happening. That is telling me an indirect proof is needed here. All right, an indirect proof. If you are being asked to prove something is not happening, an indirect proof is needed. All right, so here's the new approach to this. And just let me go through the proof first, please. All right, and then at the end, I'll explain why everything worked. Now, you can put your givens first. That's fine. All right, but right after your givens, or in the first step, whichever you prefer, we need, in an indirect proof, what's called an assumption. And the assumption is going to be the opposite, ready? The opposite of our proof statement. All right, so we are going to assume the opposite of angle A not congruent to angle C. So what would be the opposite of this? Angle A is congruent to angle C. So we are going to assume that angle A is congruent to angle C. And watch where this leads us right now. Okay? Watch where this leads us. So I'll give you a second. Go ahead and mark your diagram. I have AB congruent to BC. And I have angle A congruent to angle C. And you're probably wondering how that other given BD does not equal BE is going to come into play. Oh, it will. It will. Okay, here's what I need your help in. And you don't understand why yet, but you will at the end. Can you help me prove the two overlapping triangles congruent here? You have enough info to do that. All right, help me prove. Now we're going back to side, 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 side angle, side, HL, all that good stuff. Can you help me prove these two overlapping triangles congruent? What do you already know? I got a pair of angles from the assumption and pair of full sides. So I just need one more from you guys. All right, I need one more from you guys. Al, what do you got back there? Okay, that was a fun talk. Hi, Dewey. Where's the other angle? So I need the reflexive angle to write down, yes? Okay, so I need angle B congruent to itself. And is everyone in agreement now those triangles are congruent? All right, so let's write down a good statement now. So triangle, let's see, I'll go ABE on mine. If I go ABE, I got to match that up with what now? CBD, all right. And what was the method again there, Dewey? Yep. Okay. Now that you know the triangle's congruent, aren't all the corresponding parts congruent? Specifically, what do you know about side BD? Side BD should be congruent to what? Side BD should be congruent to what corresponding part in the other triangle? Side. Okay, yeah. Hold on. Some of you are like, wait a second here, boss. BD congruent to BE by CPCTC. Some of you already chimed in. I got a huge problem with this proof right now. Big time problem. I don't know if anybody sees it. How can BD be congruent to BE, yet in the givens it's not? That's a problem, isn't it? That's a contradiction, isn't it? So watch, ready? I'm going to try to put this all together. I'm going to go slow a couple times. What did we assume was true? That A was congruent to C. And look where that led us to. This statement right here. Is this a true or a false statement? It is false because in the givens we knew they weren't equal. Which would mean what about our assumption then? It's, ready? It's false. Then what's got to be true? The opposite, which is A does not equal C. All right, let me go through that again. We assumed A was congruent to C, and where did that lead us to? A false statement, a contradiction of our givens. All right, we know this is not true, which means our assumption is false. So if this statement right here is false, what's got to be true? The opposite, which says A is not congruent to C. Okay, so we're going to finish this up. Once I have a contradiction, I'm going to finish this up now. Come on, not now. Here we go. By saying, okay, angle A then is not congruent to angle C. And here's our final reason in any indirect proof we do. Our assumption led to a contradiction. Ooh, contradiction. TRI or TRA? And not only do I need you to write that as your last reason, but I also need you to tell me the steps that the contradictions happen. So what two statements contradict each other? And 2, well, not 2 and 6. What was our contradict? Because that was our final response here. 1 from the givens, right? 1 and 5. All right, before we go to the next one, because 1 doesn't make you great, let's put this all together here. How did I know I needed to do an indirect proof? Before I even started, I read through it. I needed to do an indirect proof because I'm proving something is not happening. So I started it out by my assumption. Where do I get the assumption from? Be careful, not the opposite of the givens, the opposite of the proof statement. And here is your goal in every indirect proof. I did not say this yet, but you did it. The goal of any indirect proof is to contradict one of the givens. All right. Say the opposite of one of these is true. All right. Say the opposite of, prove the opposite of one of these. All right. And once you do that, then your assumption led to a contradiction. Anything you want to ask here before we go on to a second one? All right. Here we go. Does everybody see why I need a indirect proof? Let's start there. Why do I need an indirect proof? Prove BD does not bisect AC. And again, the assumption can come in the first, second step, doesn't matter. What would be your assumption here in this proof? What are we going to assume is true? BD bisects AC. And now you can remember, use that assumption, treat it like a given. All right, treat it like a given. All right, before I mark my diagram, you're going to have to contradict one of these givens. What do you think is going to be the easiest one to contradict? Out of those two givens, which one do you think it's going to be the easiest to contradict? Prove ABC is not isosceles, and how are you going to contradict it? Prove it is isosceles. So that's our goal right now. Help me get triangle ABC to be isosceles, and I'll contradict one of the givens. All right, so mark your diagram up however you want. Ooh, altitude. That's a nice one from this unit. What's an altitude do? Vertex to D, it's a perpendicular line, so it's going to form a, yep. And then bisects, BD bisects AC, so I can put AD congruent to DC. Remember, these markings, have they gone in my statements reasons yet? No, just because they're marked doesn't mean you're good to go yet. We still got to write all this. All right, can you help me get it to be isosceles? So I'll have a contradiction. All right, let me just put in AD congruent before I forget. AD is congruent to DC. Definition of bisects. What else do I need to put in my proof? What else did I mark that it's not in there yet? Okay. You can go right to saying they're right angles, but not because perpendicular lines form right angles. This is going to have a different reason for it. So angle BDA and angle, what do I have there, BDC? Okay, you can't tell me perpendicular lines form right angles because I didn't have perpendicular lines. What did I have instead, though? I had an altitude, so you could say definition of an altitude. Then what do I have to say about those right angles? They are congruent. Yep, this doesn't change. Right angles are congruent. Remember our goal, make it isosceles, so that contradicts a given. All right, I've done enough now. You guys can take over there. Got to make it isosceles somehow. Vincent, what's your next move? Our good buddy, right? The old reflexive. Wondering where you guys are going here. Got to make it isosceles. Where else can I go now? Hi, Sinead. So, by what method? Yep, those two triangles are now congruent. Side angle side. What are the triangles? ADB. Congruent to, let's see, ADB. What was the other on the other side? CDB. Okay, triangles are congruent. Where else are you going here? Need to make it isosceles. That's our goal. Make it isosceles. Hi, Ryan. Okay, I could go one of two ways right now. I could say BA congruent to BC, or anybody have a different one now? Angle A congruent to angle C. Either one is going to make the triangle isosceles and be true by CPCTC. So I'll go AB congruent to BC. You haven't had this is not a contradiction yet. You still got to tell me what about the triangle ABC. It's isosceles, yep. How'd you know it was isosceles? Two congruents in a triangle. Two congruent sides imply isosceles, or two congruent angles, depending on how you did it. And then finally, what do I have now in this proof? I have a given that says it's not isosceles, and then in step 9, I'm saying it is isosceles. So my assumption must be false. So what's got to be true? BD does not bisect AC. Once you have that contradiction, you're good. Look at that, 10 steps, huh? Big boy, big girl proofs. So AC does not bisect. This thing is long. AC. I know. Should have been BD. And then same last reason, assumption led to. I forgot to mention something too. Hold on. What lines was the contradiction in? 1 and 9. Yep. Could be 2 and 9 too if you put all your assumption first and given second. To all my lazies out there, ALTAC. Assumption led to a contradiction. No go. No go. There's no abbreviation here. Sorry. All right. ALTAC next going to cut it for me. All right. Assumption led to a contradiction. All right. All right. So now it's time for me to take the gloves off and to try one on your own or in your group. Let me see it when you're done. Let me see it when you're done, please. And then once you're good, you can keep going on to the homework ones.